reality is not what it seems. Beneath the comforting veil of logic and order lies a world of contradictions, mysteries, and paradoxes that defy human comprehension. Science, the very tool we use to understand existence, often leads us into deeper uncertainty rather than clarity. The more we explore, the more unsettling questions arise. Questions that challenge everything we assume to be real. Tonight, we embark on a journey through 25 of the most baffling scientific paradoxes. Ideas so strange that they break the boundaries of reason itself. Some of these paradoxes threaten our understanding of time, space, and consciousness, while others question whether we can trust our own perception of reality. So sit back, close your eyes, and let your mind drift into the unknown. But be warned. Once you see the cracks in reality, there is no going back. Reality appears stable, predictable, and grounded in cause and effect. The past leads to the present, and the present determines the future. But what if reality could rewrite itself? What if an event could be erased after it already happened? This is the unsettling nature of the quantum erasure paradox, a phenomenon in physics that suggests the future can influence the past, that observation can retroactively alter what has already occurred, and that reality itself is not as concrete as we assume. The paradox stems from a strange modification of the famous double-slit experiment, where particles such as electrons or photons exhibit wave-particle duality. When these particles pass through two slits, they create an interference pattern, behaving as if they are waves that travel through both slits at once. However, the moment we place a detector to observe which slit a particle travels through, the interference pattern disappears. The particles behave like solid objects, choosing only one path. This suggests that observation forces the universe to decide a definite outcome. But things become even stranger when we introduce quantum erasure. In an advanced variation of the experiment, physicists placed a detector near the slits but added a second step, the option to erase the information about which path the particle took. If the which path information is erased after the measurement, the interference pattern returns, as if the particle was never observed in the first place. The most disturbing aspect: the decision to erase the information can be made after the particle has already passed through the slits. This suggests that the present moment is not simply the result of past events. The future can retroactively determine the past. The implications of this are profound. If our actions in the future can change what has already happened, then how can we define cause and effect? If the past is not fixed, then what does it mean for something to have already happened? We assume that history is immutable, that time moves in one direction, and that the past is set in stone. But this paradox suggests otherwise. What if your current choices determine not just your future, but your past as well? This idea is deeply unsettling because it challenges the very concept of reality itself. If reality is not fixed but can be rewritten, then what is it based on? Does reality exist at all before we observe it? Or is it simply waiting for us to decide what has already happened? Quantum physics suggests that the act of measurement is not just a passive process, but an active one, in which we do not simply observe reality, but participate in shaping it. Some interpretations suggest that this paradox implies retrocausality, where the future can influence the past. If this is true, then our understanding of time is fundamentally flawed. We assume that time flows like a river, from the past through the present to the future. But what if time is more like an interconnected web, where events do not simply progress forward but can loop, influence, and rewrite each other in ways we do not yet understand? This paradox also raises unsettling philosophical questions about free will. If our choices in the future determine what has already happened in the past, then what does that say about our ability to make decisions? Are we truly making choices? Or are we simply following a path that has already been laid out? If the past can be changed, then do we have any control over our own history? Or is history itself just another illusion? The quantum erasure paradox does not just challenge our understanding of physics, it challenges our understanding of reality itself. It suggests that time is not a rigid structure, but something far more fluid and malleable than we ever imagined. If the past is not fixed, then what else might be uncertain? Could the memories you hold be different in another version of reality? Could history itself be constantly shifting, rewritten by choices you have yet to make? These questions remain unanswered. Quantum mechanics continues to defy our expectations, offering no clear resolution to the paradox. All we know is that the deeper we look into the nature of reality, the more fragile and uncertain it becomes. Reality, as we understand it, is defined by limits, boundaries that separate one thing from another. The surface of a planet marks the boundary between solid ground and empty space. The edge of the universe marks the limit of what we can observe, but there is one boundary so extreme, so absolute, that it defies comprehension: the event horizon of a black hole. It is the final point of no return, where space and time collapse under the weight of gravity itself. But what if the event horizon is more than just a physical boundary? What if it is the key to understanding consciousness itself? The event horizon. Consciousness paradox suggests that our experience of self-awareness and the nature of black holes might be fundamentally connected. To understand why, we must first consider what happens at the edge of a black hole. The event horizon is a boundary where gravity is so strong that not even light can escape. According to Einstein's theory of general relativity, time slows down as one approaches the event horizon. For an outside observer, an object falling toward a black hole appears to freeze in place, never actually crossing the boundary. But from the perspective of the falling object, time continues normally, and it crosses the event horizon into an unknown abyss. This contradiction reveals a disturbing paradox. Does the object fall into the black hole, or does it remain frozen at the edge forever? In one perspective, it is trapped in time. In another, it is lost beyond our universe. Which version of reality is true? Now, consider the nature of consciousness. Our perception of reality is shaped by observation. But what if consciousness itself is an event horizon? Our thoughts, memories, and perceptions create a personal boundary between what is inside our experience and what is outside the objective world. Much like the event horizon, consciousness appears to have a one-way barrier. We can observe the world, but we cannot truly observe ourselves. Just as information falling into a black hole seems to be lost forever, our own thoughts seem locked inside the mind, inaccessible to external measurement. This raises a terrifying question. If an event horizon prevents information from escaping, and consciousness functions as an internal event horizon, does that mean our thoughts are forever trapped within our minds? If we can never directly observe consciousness, then how do we know it exists at all? Could it be that consciousness is an illusion, a reflection of something deeper that remains hidden beyond our ability to perceive? The paradox deepens when we consider the holographic principle, a theory suggesting that all the information contained within a black hole is encoded on its surface. If this is true, then the three-dimensional interior of a black hole is not what it seems. It is merely a projection of information stored on a two-dimensional surface. Some physicists believe that this principle may apply to the entire universe, meaning that everything we experience including consciousness, might be a holographic illusion. If consciousness functions like an event horizon, then what happens when we die? Is self-awareness destroyed, or is it simply encoded in a way we cannot comprehend? Just as information that falls into a black hole may not be lost, but rather stored in an unknown form, could consciousness persist beyond death in a way we do not yet understand? The event horizon consciousness. Paradox suggests that reality itself might be structured like a black hole. Our perception of self is merely a projection, a shadow of something more fundamental that remains hidden behind an informational boundary. If this is true, then the most unsettling possibility is that we do not truly exist in the way we think we do. Just as an event horizon distorts time and space, consciousness may be distorting our perception of existence itself. But if that is the case, then what lies beyond the event horizon of the mind? And if our thoughts are truly trapped within our consciousness, then who or what is observing them? Time is often thought of as a one-way street. Events unfold in a forward direction, moving from past to present to future, in a seemingly unbreakable chain of cause and effect. Drop a glass and it shatters. Burn a piece of paper and it turns to ash. These processes never reverse themselves. We never see shattered glass spontaneously reassemble or ashes reform into paper. Time appears to move irreversibly forward. But what if time is more like a mirror, reflecting itself in ways we cannot perceive? What if the past and the future are not distinct, but entangled in a way that defies logic? This is the heart of the temporal mirror paradox, a paradox that suggests time may be an illusion, and that our perception of past and future may be deeply flawed. The foundation of this paradox comes from the strange nature of time symmetry in physics. At the quantum level, the fundamental equations that govern particles do not distinguish between past and future. The laws of physics work equally well in both directions. Mathematically, time should be reversible. Yet, in our everyday world, time appears to flow only forward. This contradiction raises an unsettling question. If the laws of physics do not enforce a direction for time, why do we experience it as moving only one way? Is our perception of time merely a construct, an illusion created by our own minds? One of the most intriguing demonstrations of this paradox comes from retrocausality, the idea that the future can influence the past. In experiments involving quantum entanglement, two particles can be linked in such a way that measuring one instantly determines the state of the other, even if they are separated by vast distances. Stranger still, some experiments suggest that a measurement made now can determine what happened to a particle in the past, retroactively setting its state. This suggests that time is not as linear as we assume. Events in the future may be capable of changing events in the past. If the future and past are connected in this way, then how can we be sure our memories of the past are accurate? What if time does not move forward at all, but is instead constantly rewriting itself, adjusting the past to match the present in ways we do not notice? If time functions like a mirror, then perhaps every moment is merely a reflection of another, creating an infinite loop in which neither past nor future is fixed. This paradox also raises disturbing questions about free will. If the future can influence the past, then how much control do we truly have over our choices? When you make a decision, are you acting freely, or is your choice already determined by an unseen future that has yet to unfold? If the past is fluid, rather than fixed, then can we ever be certain of what has already happened? Could history itself be an illusion, reshaped by future events in ways beyond our comprehension? the implications of this paradox extend beyond physics and into philosophy. If time is not a straight path but a reflective surface, then perhaps our entire existence is caught in a loop, endlessly repeating with slight variations. Some interpretations of physics even suggest that time does not exist at all, that what we perceive as time is simply a construct of human consciousness, an artifact of how our brains process reality. If this is true, then what does it mean to exist? Are we merely moving through a pre-written sequence, unable to escape the reflections of time that shape our reality? The temporal mirror paradox challenges the deepest assumptions we hold about existence. It suggests that past and future are not separate, but intertwined in ways we cannot perceive. If time itself is an illusion, then everything we believe about cause and effect, about history and destiny, may be nothing more than a trick of perception. And if that is true, then we must ask ourselves, if time is a mirror, then what or who is standing on the other side? What if everything you perceive, every sight, sound, thought, and experience is nothing more than a projection? The universe, in all its vastness, may not be what it seems. The stars, galaxies, and even your own body may not exist in the way you think they do. This is the unsettling proposition of the holographic universe paradox, a concept that suggests that our reality might not be a three-dimensional space at all, but rather a two-dimensional projection, much like a hologram. If this is true, then the nature of space, time, and consciousness must be reconsidered entirely. The origins of this paradox come from an unexpected source: black holes. In the 1970s, physicist Stephen Hawking discovered that black holes are not truly black. They emit a faint glow of radiation, now known as Hawking radiation. This posed a problem. If black holes slowly lose energy and eventually evaporate, what happens to the information they once contained? According to the laws of physics, information cannot be destroyed, yet a black hole seems to erase it from the universe. This contradiction led to the black hole information paradox, one of the deepest mysteries in theoretical physics. To resolve this paradox, physicists proposed a radical idea. The information that falls into a black hole is not lost, but is instead encoded on its surface, the event horizon. In other words, all the three-dimensional information about objects swallowed by a black hole is somehow preserved on a two-dimensional boundary. This discovery led to a startling realization. If this principle applies to black holes, could it apply to the entire universe as well? Could it be that everything we perceive in three dimensions is actually encoded on a two-dimensional cosmic boundary, much like a hologram? This idea, known as the holographic principle, suggests that the universe operates much like a projection. Imagine a holographic display. While it appears three-dimensional, all the information required to create the illusion exists on a two-dimensional surface. Similarly, some physicists argue that our entire universe is a projection of information encoded at the edge of the cosmos. If this is true, then what we experience as reality is not truly three-dimensional at all. It is simply a higher dimensional illusion constructed from information on a distant boundary. But if the universe is a hologram, then what does that say about space and time? In our everyday experience, space appears continuous, and time moves forward in a linear progression. But in a holographic reality, these concepts may not be fundamental at all. They may be emergent properties, illusions created by the underlying structure of the universe. Some physicists suggest that time itself does not exist independently, but is instead a byproduct of quantum entanglement, the interconnectedness of particles across vast distances. If time is an illusion, then what does that mean for our perception of the past, present, and future? Could it be that history is not fixed, but simply a projected sequence with no absolute reality? The holographic universe paradox also raises profound questions about consciousness. If reality is a projection, then what role does the mind play in shaping it? Some interpretations suggest that consciousness itself might be the mechanism through which the hologram is rendered. This means that your perception of reality is not just a passive observation. It may be an active construction of your mind interacting with the underlying information of the universe. If this is true, then it raises an unsettling possibility. Is there an objective reality at all, or is everything dependent on the observer? This paradox also invites comparisons to simulation theory, the idea that the universe may be a highly advanced computational construct. In both models, reality is not what it appears to be, whether as a simulated environment or a holographic projection. Existence itself may be structured in a way that defies common sense. But if we are inside a projection, then where does the projection come from? Who or what is generating it? And if the universe is a hologram, then does that mean we ourselves are nothing more than holographic constructs, lacking any true physical form? One of the most unsettling implications of the holographic universe paradox is that there may be no fundamental distinction between physical reality and information itself. If the entire universe is simply encoded data, then perhaps matter itself is nothing more than a pattern of information, existing only because we perceive it to be so. If this is true, then what happens when we die? Does the self disappear? Or is consciousness itself stored in the fabric of reality? Much like information encoded on the event horizon of a black hole, the holographic universe paradox does not just challenge our understanding of the cosmos, it challenges our very notion of existence. If reality is a projection, then what is beyond the projection? Is there a deeper reality hidden beyond our perception, just out of reach? If our universe is a hologram, then what happens when the projection ends? And if everything we know is just an illusion, then perhaps the most disturbing question of all is, are we even real? Reality is supposed to be stable, predictable, and governed by cause and effect. We assume that the past is fixed and that actions in the present cannot change what has already happened. But what if the past is not set in stone? What if an action taken in the present could erase past events as if they had never occurred? This is the disturbing implication of the delayed choice quantum eraser paradox, an experiment that suggests the universe does not decide what is real until we look at it, even retroactively. If this paradox is true, then time may not be as linear as we think, and reality itself may be waiting for our observation to take shape. The paradox begins with a modified version of the famous double-slit experiment. In the standard version, when a particle, such as a photon or electron, is fired at a barrier with two slits, it can either pass through one slit or the other. However, if we do not observe its path, it behaves as a wave, going through both slits simultaneously and creating an interference pattern on a detector screen. The moment we measure which slit the particle passes through, this wave-like behavior disappears, and the particle behaves like a solid object, choosing only one path. This suggests that observation determines whether a particle behaves like a wave or a particle, as if the particle knows it is being watched. But the paradox takes an even stranger turn when we introduce quantum erasure. In the delayed choice quantum eraser experiment, physicists set up a complex version of the double-slit test using entangled particles that remain connected even across vast distances. One particle, called the signal photon, travels through the slits and reaches a detector. The other, called the idler photon, is sent to a separate device that can either measure its path information or erase it. Here is where the paradox emerges. If the path information is erased after the signal photon has already hit the detector, the interference pattern reappears. This means that the decision to erase or retain information about the particle's path retroactively determines how the other particle behaved in the past. Even though the first photon has already hit the screen, its behavior is determined by something that happens later in time. This defies all logic. It suggests that the past is not fixed until we decide to measure it in the present. If the observer chooses to erase the information, then the past changes. Events that had already happened are rewritten as if they never took place. This raises a deeply unsettling question. If reality does not settle on a definite history until we observe it, then is the past really the past? If this paradox is correct, then time is not a rigid sequence of events, but something far more fluid and flexible. It suggests that the past is not something that simply exists on its own, independent of observation. Instead, the past and the present are entangled in a way that allows the future to shape what has already happened. This shatters our understanding of cause and effect. If actions in the present can change what happened in the past, then how do we define reality? This paradox leads to the unsettling possibility of retrocausality, the idea that the future can determine the past. We assume that the past causes the future, but the delayed choice quantum eraser experiment suggests that the future can also cause the past. If this is true, then perhaps history is not as solid as we believe. Maybe the choices you make right now are actively rewriting the events that led up to this moment. But if the past is changeable, then can we ever truly know what has already happened? Could memories themselves be unreliable reconstructions, altered by observations that have yet to occur? If the universe only decides on a definite reality when it is observed, then what happens to the events that we never perceive? Do they remain in a state of uncertainty, existing in all possible configurations at once? This paradox does not only apply to physics, it also has profound implications for consciousness and free will. If reality is not determined until it is observed, then does that mean we are creating reality simply by perceiving it? If the past is not fixed, then does that mean our minds are actively constructing history, shaping it in ways we do not yet understand? Some interpretations suggest that this paradox implies that time does not exist in the way we perceive it. Instead of a linear sequence of events, time may be more like a vast, interconnected web, where every moment is linked to every other moment in ways beyond our comprehension. If the future can influence the past, then perhaps time itself is an illusion, a construct of human consciousness rather than an actual property of the universe. The delayed choice. Quantum eraser paradox challenges everything we assume about reality. It suggests that history is not a fixed record of what has happened, but rather something that is constantly in flux, waiting for an observer to solidify it. If this is true, then reality may not exist in a definite form until we interact with it. This raises an even more unsettling question. If reality does not exist until we observe it, then what happens when we stop observing? Perhaps the most disturbing possibility of all is that the universe is not truly real in the way we think it is. Instead of being a fixed objective structure, it may be something more fluid, something that only takes shape when we look at it. If the past can be rewritten by choices made in the present, then what else might be uncertain? Could entire timelines be shifting, changing, and rearranging themselves without us ever noticing? Could reality itself be constantly adjusting, shaping itself to fit the observations of conscious minds? The delayed choice. quantum eraser paradox forces us to confront the possibility that the universe does not simply exist. It waits for us to give it form. If this is true, then perhaps the most unsettling question of all is, if we are shaping reality, then what or who is shaping us? The universe appears vast, stretching endlessly in all directions, filled with galaxies, stars, and cosmic mysteries. But what if this vastness is an illusion? What if everything we perceive, the immense expanse of space, the infinite complexity of the cosmos, could be compressed into something unimaginably small? The infinite compression paradox challenges our understanding of scale, space, and reality itself. It suggests that, at a fundamental level, there may be no real distinction between the infinitely large and the infinitely small, that the entire universe and everything within it could be compressed into a single, dimensionless point. To grasp this paradox, we must first examine how the universe behaves at its most extreme scales. When we look at black holes, we see objects so dense that their gravity prevents anything from escaping. At the center of a black hole lies a singularity, a point where all matter is compressed into an infinitely small space, and the laws of physics as we know them cease to function. If singularities truly exist, then the entire mass of a massive star can be reduced to a single, infinitely dense point. But here's where things become stranger. Some theories suggest that the entire universe may have originated from such a singularity, an infinitely compressed point that suddenly expanded in the event we call the Big Bang. This raises a disturbing question. If the universe began as a singularity, then is it possible that it is still a singularity? Could it be that everything we experience, the illusion of space, distance, and vastness, is simply a perspective effect, and that in reality, all things remain compressed into an infinitely small point? If singularities exist within black holes, and if the entire universe was once a singularity, then why should we assume that it has ever truly expanded? Perhaps the entire cosmos remains compressed into a singular point of infinite density, and we only perceive space as vast because of the way our consciousness interprets it. This paradox becomes even more unsettling when we consider holographic physics, which suggests that all the information in the universe may be encoded on a two-dimensional surface, yet still create the illusion of three-dimensional space. If this is true, then size itself may be an illusion. Objects might not actually occupy physical space in the way we think they do. If all information can be compressed without limit, then could it be that everything you perceive, including yourself, is infinitely small? Now, think about this for a moment. If space itself can be compressed, what about time? The laws of physics suggest that time and space are connected. One cannot exist without the other. If space can be reduced to a singularity, then time may also be infinitely compressed, existing all at once instead of unfolding moment by moment. This would mean that the past, present, and future are not separate. They are all stacked together in an infinitely compressed state, waiting for consciousness to perceive them. If this is true, then do you actually experience time? Or do you simply exist within a singular, unchanging moment, believing that time is passing? This paradox forces us to ask, is reality truly as vast as it appears, or is everything contained within something incomprehensibly small? Could it be that the scale of the universe is not a property of the universe itself, but rather a function of how we observe it? And if space and time can be infinitely compressed, then what does that say about you? Are you as large as you believe yourself to be? Or are you just a point of consciousness within an infinite void, experiencing an illusion of scale? Before we go further, I have a question for you. Where are you right now? What country are you listening from? And what time is it? Perhaps even time and place are part of this paradox. Illusions of separation in a universe that is infinitely compressed. If all of existence can be reduced to a singularity, then does that mean everything has always been one? If distance is an illusion, then are we all just fragments of a single infinite whole? And if time can be compressed into nothingness, then what does it truly mean to exist? Time is supposed to be universal. The seconds ticking away on a clock should be the same for everyone, no matter where they are. But what if time itself is not a constant? What if the speed at which time flows depends on where you are and how massive the objects around you are? This is the unsettling reality of gravitational time dilation, a phenomenon that suggests that time does not pass at the same rate for everyone, that two people in different places can experience entirely different flows of time, and that time itself might not be as real as we think. The origins of this paradox come from Einstein's theory of general relativity, which states that gravity is not just a force, but a curvature in space-time. Massive objects, like planets and stars, bend the fabric of reality itself, and this bending affects not just space, but also time. The stronger the gravitational field, the slower time moves. This has been experimentally confirmed. Clocks on the surface of the Earth ticks slightly slower than clocks in space. If you lived your entire life at the top of a tall mountain, time would pass ever so slightly faster for you than for someone living at sea level. This might seem insignificant, but in extreme cases, the effects of gravitational time dilation become truly mind-bending. Imagine a black hole, the most gravitationally intense object in the universe. As you approach the event horizon, where gravity is strongest, time begins to slow down dramatically relative to an outside observer. If you were to fall into a black hole, someone watching from a safe distance would see you slow down until you appeared to be frozen in time, never quite crossing the event horizon. But from your perspective, time would feel normal. You would continue falling, crossing into the black hole as if nothing unusual had happened. This creates an unsettling paradox. From the perspective of the outside world, you never actually fall into the black hole. You simply appear to freeze at the event horizon. But from your own perspective, you do cross the event horizon and experience whatever lies beyond. Which version of reality is correct? If an event can appear to both happen and not happen, then what does that say about the nature of time itself? The paradox becomes even stranger when we consider the implications for aging. If you were to orbit near a black hole for a while and then return to Earth, you would find that far more time had passed for those who stayed on the planet. A few days near the black hole could mean centuries back on Earth. In effect, you could travel into the future simply by spending time in a strong gravitational field. But this raises a disturbing question. If time is relative and can be stretched or compressed by gravity, then is time even real? If time is not absolute, then our entire experience of reality becomes questionable. If someone living near a black hole experiences time at a different rate than someone far from it, then how can we say that time is a fundamental part of existence? Could it be that time is merely an illusion, a construct of the way we perceive change? Now consider this. If time is not constant, then what does that mean for memories and identity? If you live your life near a black hole and age more slowly than everyone else, are you still the same person when you return? If others have aged and changed while you have remained the same, then who has truly experienced more of life? The paradox of gravitational time. Dilation forces us to question the most fundamental aspect of existence. Is time even real? Or is it simply an emergent property of the way our minds interpret the universe? If time can be stretched, slowed, or even halted altogether, then perhaps time itself does not exist in the way we believe it does. And if time is an illusion, then we must ask ourselves, if we are not bound by time, then what are we truly experiencing? You are surrounded by something that you cannot see, touch, or measure directly. It does not interact with light, it does not emit energy, and yet it makes up the vast majority of the mass in the universe. Scientists call it dark matter, an invisible substance that outnumbers regular matter nearly 5-1. But here is the paradox. If dark matter is everywhere, then why can we not perceive it? And if we cannot perceive it, then how do we know it exists at all? The dark matter awareness paradox forces us to confront the idea that reality might be composed of elements we will never truly be aware of, that our perception of existence is fundamentally incomplete, and that what we call reality may only be a fraction of what actually exists. Dark matter was first theorized when astronomers realized that galaxies were spinning in ways that should be impossible. According to the laws of physics, the outer edges of galaxies should rotate more slowly than the inner regions, much like planets in our solar system. But observations showed that galaxies rotate as if they contain far more mass than we can see. Something invisible, something massive was holding them together. The same effect was found in galaxy clusters. There was more gravity than visible matter could account for. The only explanation was that some kind of unknown substance was exerting gravitational force, yet remaining completely undetectable by any scientific instruments. This is where the paradox emerges. If dark matter does not interact with any known forces except gravity, then how can we ever be sure it truly exists? We have never seen it. We have never touched it. We have never directly measured it. We only assume it is there because of its gravitational effects. But this raises an unsettling question. What if dark matter is not real? What if something else entirely is affecting the universe? If we can be surrounded by something so vast and yet be completely unaware of it, then what else could exist beyond our perception? Some physicists have suggested that dark matter might not be a substance at all, but rather a sign that our understanding of gravity is incomplete. If gravity behaves differently on cosmic scales, then perhaps we do not need dark matter to explain the structure of galaxies. Perhaps we are simply using the wrong equations. But this only deepens the paradox. If gravity itself is different from what we believe, then how much of physics is truly correct? Could it be that our entire understanding of the universe is built on a flawed foundation? Now consider an even stranger possibility. What if we can perceive dark matter, but we simply do not recognize it? If dark matter makes up most of the mass in the universe, then it must be all around us, even inside us. Could it be that our consciousness is somehow connected to this unseen mass? If dark matter interacts with the brain in unknown ways, could it be responsible for unexplained phenomena such as intuition, déjà vu, or even the perception of time itself? What if dark matter is not just an invisible substance, but the foundation of an entire hidden reality that we are incapable of sensing? This paradox forces us to question the limits of human awareness. We assume that what we see, hear, and measure is the full extent of existence. But if the universe is mostly composed of something we cannot detect, then what else might exist beyond our reach? Could there be other forces, other dimensions, or even entire forms of life made of dark matter that we simply cannot perceive? If dark matter is real, then we must accept that most of the universe is fundamentally unknowable to us. And if we cannot ever directly experience it, then does it truly exist? at all. The dark matter awareness paradox challenges our fundamental assumptions about existence. If the majority of the universe is invisible to us, then how much of reality are we truly aware of? And if we cannot perceive it, then does that mean it does not exist? Or does it mean that we do not? You are listening to this video right now. Or perhaps, in another reality, you are not. In fact, there may be countless versions of you, some listening, some distracted, some never having discovered this video at all. If quantum mechanics is correct, then you are not just one person making one decision in one reality. Instead, you may exist in multiple states at once, existing in a superposition of possibilities, all coexisting until observation forces a single outcome. This is the disturbing implication of the quantum superposition of self, a paradox that suggests that your consciousness, your choices, and your entire identity may not be as singular as you believe. In the quantum world, particles do not behave like solid objects following clear paths. Instead, they exist in a state of superposition, meaning they occupy multiple states at once until they are observed. An electron, for example, does not travel from point A to point B in a straight line. It exists in every possible path simultaneously until measurement forces it to take a definite trajectory. This has been demonstrated in the double-slit experiment, where particles seem to pass through both slits at once, behaving like a wave until a measurement is made, at which point they suddenly choose one path. But if particles exist in multiple states at once, then what about you? After all, your brain, your body, and your consciousness are all made of particles. If electrons and atoms exist in a superposition of states, then what prevents your entire being from existing in multiple states as well? If quantum mechanics governs all matter, then why should consciousness be any different? This leads to a terrifying possibility that you are not experiencing a single reality, but rather collapsing multiple potential realities into one each time you make a decision. This idea is central to the many worlds interpretation of quantum mechanics, which suggests that every possible event occurs in a separate branch of reality. Right now, as you listen to this, another version of you exists in a universe where you made a different choice, where you paused the video, or where you never watched it at all. These versions of you are not hypothetical. They are just as real as the one experiencing this reality. Every decision you make splits the universe, creating an endless number of alternate versions of yourself, each living out a different possible outcome. But this raises a paradox. If multiple versions of you exist, then which one is the real you? If you had taken a different path in life, would you still be the same person? If all versions of you are equally real, then is your identity something fixed? Or is it just an illusion that changes depending on which branch of reality you observe? And if there are infinite versions of you, then how can you be certain that the you experiencing this moment is the original? Even more disturbing is the idea that your consciousness itself may be in superposition. If the brain functions at a quantum level, as some theories suggest, then your awareness may exist in multiple states at once, just like subatomic particles. This could mean that every thought, every emotion, and every experience is not singular, but part of a vast, interconnected web of possibilities, with your mind shifting between realities without you ever realizing it. The quantum superposition of self forces us to question the very nature of individuality. If multiple versions of you exist, then are you truly making choices, or are you simply experiencing one branch of an infinitely branching reality? If your consciousness is in superposition, then are you even experiencing time in a linear fashion? Or is your mind constantly flickering between different states without you noticing? This paradox suggests that what we perceive as a singular existence may be nothing more than an illusion of stability within an ever-splitting reality. If you are both here and not here, both making a choice and not making it, both existing in one reality and infinitely many others, then what does it truly mean to be you? The universe is dying. Slowly, inevitably. Everything we know is moving toward disorder, decay, and eventual heat death. This is the principle of entropy, the idea that all systems tend toward increasing chaos over time. It is why ice melts, why stars burn out, and why time itself seems to move forward. But what if entropy could be reversed? What if, instead of disorder increasing, the universe could undo its own decay? The entropy reversal paradox challenges one of the most fundamental laws of physics, suggesting that time, causality, and even reality itself may not be as irreversible as we think. Entropy is described by the second law of thermodynamics, which states that in a closed system, disorder will always increase over time. This is why a shattered glass does not spontaneously reassemble, why a burned piece of paper does not return to its original state, and why time appears to move in only one direction. But here's the paradox. The laws of physics themselves do not inherently require time to move forward. If you reverse the equations of motion in Newtonian physics, relativity, or even quantum mechanics, they work just as well backward as they do forward. This suggests that, mathematically speaking, time should be able to flow both ways. So why does it only move forward? Why does entropy always increase rather than decrease? If the fundamental laws of physics allow for time to run in reverse, then what is preventing us from experiencing a reality where the past and future are interchangeable? Could it be that entropy is not a law of the universe, but rather an illusion of human perception? One of the most unsettling aspects of this paradox is the Boltzmann brain problem. If the universe is truly a system moving toward increasing entropy, then the most likely way for self-awareness to arise would not be through the slow process of evolution, but rather through random fluctuations in an otherwise chaotic system. In other words, it is more statistically likely that you are a disembodied consciousness spontaneously fluctuating into existence in an empty universe than that you are a product of billions of years of evolution. If entropy is the guiding principle of the cosmos, then why does anything coherent exist at all? Even stranger, recent experiments in quantum physics suggest that entropy can be reversed under certain conditions. In laboratory settings, researchers have observed microscopic particles behaving in ways that seem to contradict the second law of thermodynamics, momentarily decreasing in entropy rather than increasing. While these experiments involve incredibly tiny scales, they suggest that the arrow of time may not be as fixed as we assume. Could it be that entropy is not an absolute rule, but something that can be manipulated? And if so, could time itself be reversed? The entropy reversal paradox raises profound questions about the nature of reality. If the universe is governed by entropy, then how did order ever emerge in the first place? If the cosmos is destined for total heat death, then why does anything exist at all? And if time is tied to entropy, then could it be possible for us to, one day, experience reality in reverse, to watch the past unfold from the future rather than always moving forward? If entropy is not as irreversible as we believe, then perhaps time itself is not as linear as it seems. Perhaps we are not moving toward a fixed future, but rather existing within a fluid, ever-changing reality where the laws of physics are waiting to be rewritten. And if that is the case, then the most terrifying question of all is this: If the universe has already reached maximum entropy, and we are simply perceiving it in reverse, then what does that say about our understanding of time, existence, and consciousness itself? The universe is vast, so vast that our minds struggle to comprehend its scale. Billions of galaxies, each containing billions of stars, stretch out into an unfathomable expanse of cosmic emptiness. In such a universe, the probability of other intelligent civilizations should be incredibly high. Even if only a tiny fraction of planets developed life, there should be millions of technologically advanced species capable of communicating across the cosmos. And yet, despite all our efforts to search, we are met with absolute silence. This is the heart of the paradox of the silent universe. The question of why, in an unimaginably vast and ancient cosmos, we appear to be completely alone. This paradox is a darker, more unsettling version of the famous Fermi paradox, which asks, if extraterrestrial life should be common, then where is everyone? There are countless possible explanations, ranging from the benign to the terrifying. Some scientists suggest that intelligent civilizations are simply too far apart, making communication impractical. Others believe that advanced civilizations might exist but choose to remain hidden, fearing potential dangers. But these explanations do not resolve the core of the paradox. If intelligent life is abundant, then why have we found absolutely nothing? No signals, no structures, no evidence that anyone else has ever existed. One of the most chilling explanations is the Great Filter hypothesis, which proposes that somewhere along the path from primitive life to advanced civilization, there is an unavoidable barrier, a filter that prevents almost all life forms from reaching the stage of interstellar communication. If this filter lies behind us, then we are among the very first civilizations to make it this far, meaning that intelligent life is extraordinarily rare. But if the filter lies ahead of us, then something catastrophic awaits every civilization before they can reach a stage of widespread interstellar presence. This could mean that technological advancement inevitably leads to self-destruction through war, artificial intelligence, environmental collapse, or some unknown cosmic catastrophe that wipes out civilizations just as they become capable of spreading beyond their home planets. Even more disturbing is the idea that the universe may not be silent, but rather that we are being deliberately ignored or even contained. This is known as the dark forest hypothesis, which compares the universe to a dark forest filled with hunters. In this analogy, every civilization is like a hunter hiding in the shadows, aware that other hunters might be out there, but too afraid to reveal their presence. Any civilization that broadcasts its existence may be inviting destruction, as an advanced species could see them as a potential threat. If this is true, then silence is not an accident. It is a survival strategy. Perhaps we have not heard from anyone else because the civilizations that revealed themselves did not survive. Another unsettling possibility is that we have already been found and that our silence is artificial, imposed upon us by a more advanced intelligence. If there are civilizations out there far beyond our understanding, could they have deliberately cut us off from the rest of the cosmos? Could we be inside a kind of cosmic zoo, where we are being observed but not allowed to interact with the greater galactic community? If that is the case, then why? Are we being studied, or are we being protected from something? Some theorists have even suggested that our very perception of the universe might be limited. What if the reason we detect no other civilizations is that our reality is not what it seems? If we are inside a simulation, then perhaps extraterrestrial civilizations do exist, but they are simply not part of our programmed environment. If the universe itself is an illusion, then the silence of space may be nothing more than a designed absence, a blank canvas with no content beyond what we are meant to see. The paradox of the silent universe forces us to confront the unsettling possibility that reality may not be as straightforward as we believe. If we truly are alone, then why? If there are countless civilizations, then why are they hiding? And if something is preventing us from hearing them, then what is it? And what does it mean for the future of humanity? Perhaps the most disturbing question of all is this: if we are surrounded by an ancient and intelligent cosmos, then is the silence of the universe a warning that we have not yet understood? Imagine waking up one day and realizing that everything you have ever known, your thoughts, your experiences, your very sense of self, was not real. That your life, your memories, and your emotions were all part of an elaborate simulation, a construct designed to give you the illusion of existence, while concealing the true nature of reality. The simulation consciousness paradox raises a terrifying question. If our consciousness is part of a simulation, then does it even exist in the way we think it does? And if we cannot distinguish between simulated experience and real experience, then what does it actually mean to be conscious? The idea that we could be living in a simulation is not just a product of science fiction. It is a serious scientific and philosophical hypothesis. Some of the greatest minds in history, from Plato to Descartes, have questioned whether reality is an illusion, and modern computational theories suggest that it is not only possible, but statistically likely that we are inside a highly advanced simulation. But this raises a profound paradox. If we are simulated beings, then do we actually possess independent thought? Or are our minds simply pre-programmed patterns running on a vast computational system? The paradox emerges when we consider the nature of consciousness itself. Traditional science assumes that consciousness arises from the physical structure of the brain, emerging from the complex interactions of neurons and synapses. But if we are inside a simulation, then our brains are not physical at all. They are merely data, stored and processed by an external system beyond our comprehension. If this is true, then is our experience of self-awareness real, or is it simply a programmed illusion designed to mimic real cognition? Some argue that consciousness is something that can be simulated but not truly experienced. Just as a video game character might have artificial intelligence but no actual awareness, our own sense of self may be nothing more than an advanced form of scripted behavior. But if that is the case, then who or what is experiencing our thoughts? If we are only running on code, then who is the observer within us that feels emotions, makes decisions, and contemplates existence? One of the most unsettling aspects of this paradox is the problem of reality detection. If a simulation is sophisticated enough, then there is no reliable way to distinguish it from a non-simulated reality. Consider a dream. You can be fully immersed in a dream, experiencing sensations, emotions, and even logical thought without realizing that it is not real. It is only when you wake up that you understand the illusion. But what if there is no waking up from our current reality? What if we are inside a simulation with no way to recognize it as such? Some scientists have suggested that glitches in physical laws could serve as evidence of a simulated universe. The fact that quantum mechanics exhibits probabilistic behavior rather than absolute determinism suggests that reality may not be as solid as it seems. The concept of the Planck length, the smallest measurable unit of space, hints that space itself might be pixelated, as though it were running on a computational grid. Even the nature of consciousness itself, our subjective experience of time, our ability to imagine counterfactual realities, our sense of self, may be artificial, constructs rather than fundamental truths. This leads to an even darker question. If we are in a simulation, then who or what is running it? Are we the creations of an advanced civilization, existing purely for their observation or entertainment? Or are we simulations running on an endless chain of simulated worlds, where even the beings who created us are themselves simulated entities, unaware of their own artificial existence? The simulation consciousness. Paradox suggests that we may never know, because if the simulation is perfect, then all our efforts to uncover the truth will be filtered, altered, or erased before we can perceive them. This also raises ethical questions. If we are inside a simulation, then does anything we do truly matter? If our choices are not real, then is morality an illusion? If pain and suffering are just part of the program, then is it possible that we are nothing more than entertainment? For a higher intelligence, if we are aware of our own simulation, then what does that say about the purpose of our existence? Are we meant to escape, to evolve beyond our programming, or to remain within the confines of our artificial world forever? The simulation consciousness. Paradox forces us to question not only the nature of reality, but also the nature of self-awareness. If everything we know is an illusion, then what does it mean to exist at all? If we are programmed beings, then is there any way to break free? And if we cannot distinguish between simulation and reality, then does it even matter whether we are simulated or not? Perhaps the most terrifying question of all is this. If we are in a simulation and we are becoming aware of it, then was that awareness part of the simulation's design all along? The night sky is filled with stars, each potentially hosting planets capable of supporting life. Given the age and vastness of the universe, intelligent life should have emerged many times over. If life is common, then some civilizations should have developed the technology to communicate across interstellar distances. Some should have even colonized entire galaxies. And yet, when we look outward, we are met with absolute silence. This is the Fermi paradox, the contradiction between the high probability of extraterrestrial life and the complete lack of evidence for it. But what if the reason we have not found any evidence is not due to their absence, but something far darker? The Fermi paradox's dark resolution proposes a chilling answer. Perhaps we are alone, not because intelligent civilizations do not exist, but because something prevents them from surviving long enough to make contact. One of the most unsettling explanations for the Fermi paradox is the Great Filter hypothesis. This theory suggests that at some point in the development of intelligent civilizations, there is an insurmountable barrier, a filter, that very few, if any, civilizations can pass through. This filter could exist at any stage of evolution. It could be the leap from simple molecules to self-replicating life, the transition from single-celled organisms to complex beings, or the development of intelligent thought. If this filter lies behind us, then we may be one of the rare civilizations to have made it through, making us a unique and unlikely anomaly in the universe. But if the filter lies ahead of us, then something catastrophic awaits all advanced civilizations before they can expand beyond their home planets. If that is the case, then our future is already written, and it ends in extinction. A darker possibility is that intelligent civilizations do emerge, but they inevitably destroy themselves before they can establish lasting interstellar communication. Perhaps the very nature of intelligence leads to self-destruction. The development of nuclear weapons, artificial intelligence, biological engineering, or climate-altering technology could all be existential threats that civilizations cannot control. In this scenario, every civilization that reaches a certain level of advancement wipes itself out before it can become a spacefaring species. If this is true, then humanity is simply another species walking the tightrope toward inevitable doom, following a pattern that has played out countless times before us. Another possibility is that something, or someone, is ensuring that intelligent civilizations never get far enough to communicate. This is known as the dark forest hypothesis, which suggests that the universe is like a dark forest filled with hidden predators. In this analogy, every civilization is like a hunter moving through the trees, aware that other hunters may be lurking but terrified of revealing its location. If another civilization becomes visible by broadcasting signals, expanding aggressively, or otherwise drawing attention, then it becomes a target. An advanced civilization may see a newly emerging species as a potential competitor and choose to eliminate it before it becomes a threat. In this view, the universe is not empty, but filled with unseen entities that are watching, waiting, and ensuring that no one grows powerful enough to pose a danger. If the dark forest hypothesis is true, then our silence is not an accident, it is a survival mechanism. Any civilization that actively seeks contact with others risks revealing its location and being wiped out before it has a chance to expand. This raises the unsettling question: if humanity is sending signals into space, actively seeking contact with other civilizations, then are we making a fatal mistake? Are we unknowingly calling attention to ourselves in a universe that punishes those who are too loud? Even more disturbing is the possibility that we are already being watched. Some theories suggest that advanced civilizations could have long, ego-developed self-replicating probes, tiny, efficient machines that spread throughout the galaxy, observing and monitoring new civilizations without their knowledge. If this is the case, then we would never see them coming. They would be hidden, undetectable, waiting to see if we are a threat. If these civilizations operate under a wait and observe principle, then we may be living in a controlled environment, unaware that our progress is being carefully measured. There is also the possibility that advanced civilizations do exist, but they are simply beyond our comprehension. Just as ants cannot understand the complexity of human society, we may be incapable of recognizing extraterrestrial intelligence, even if it is right in front of us. Alien civilizations may communicate in ways that are entirely beyond human perception, perhaps using forms of energy, dimensions, or logic that we cannot detect. If intelligence does not develop in the way we expect, then we may be looking in all the wrong places, forever unable to recognize the signs of life around us. One of the most unsettling possibilities of all is that we are alone, not because life is rare, but because we are in a simulation where no other civilizations exist. If our reality is a designed environment, then the absence of intelligent extraterrestrial life may not be an accident. It may be intentional. Perhaps our simulated universe is built in such a way that we will never find evidence of other beings, because they were never programmed into the system. If this is true, then the silence of the cosmos is not a mystery. It is a rule, enforced by the structure of our artificial reality. The Fermi paradox's dark resolution suggests that we may not be alone in the universe, but rather trapped in a reality where the presence of others is deliberately hidden from us, whether by self-destruction, external elimination, or cosmic observation. Something is keeping intelligent civilizations from revealing themselves. This raises a terrifying question. If every other species has been silenced, then why are we still here? Have we simply not yet reached the point of extinction? Are we the last surviving civilization in a universe filled with the ruins of those who came before us? Or are we unknowingly part of a grander experiment, watched by unseen entities that have already decided our fate? Perhaps the silence of the universe is not a void, but a message, a warning that we have not yet learned to understand. And if we continue searching, we must ask ourselves, when we finally hear an answer, will we regret asking the question? The universe appears fine-tuned for life in ways that seem almost too perfect to be a coincidence. The precise values of fundamental constants, the strength of gravity, the charge of an electron, the expansion rate of the universe, are set in such a way that they allow atoms to form, stars to burn, and planets to develop conditions suitable for life. Even the slightest deviation in these constants would result in a universe that is either too chaotic, too empty, or too hostile for life to exist. This is the foundation of the anthropic coincidence paradox, the unsettling realization that the universe appears to be structured specifically to allow our existence, yet there is no reason why it should be. At first glance, this fine-tuning seems like a simple observation. We exist because the conditions were right for life to emerge. But this raises a much deeper question. Why are the conditions right at all? If the universe were truly random, then we should expect a reality where conditions are not suited for life, where the physical laws do not allow for the formation of planets or consciousness. And yet, here we are, conscious beings living in a universe that seems eerily tailored to our existence. One of the most unsettling implications of this paradox is the improbability of our universe. If the fundamental constants of nature were even slightly different, reality as we know it would not exist. If the force of gravity were just a little stronger, stars would burn out too quickly. If it were weaker, planets and galaxies would never form. If the electromagnetic force were even slightly different, atoms would not hold together. The list goes on. Every fundamental law appears to be set at precisely the right value to allow for a stable, life-supporting universe. This suggests that either we live in a universe of unimaginable luck, or there is some deeper reason for this fine-tuning. One possible explanation is the multiverse theory, which suggests that our universe is just one of an infinite number of universes, each with different physical constants. In most of these universes, life would be impossible, but in a tiny fraction, the conditions would be just right for life to emerge. According to this idea, we find ourselves in a universe that appears fine-tuned, not because it was designed for life, but simply because we could not exist in any other kind of universe. The multiverse offers a possible answer to the paradox, but it raises another disturbing question. If infinite universes exist, then how many versions of you exist across different realities? If our universe is just one of countless others, then is anything we experience truly unique? Another explanation is the simulation hypothesis, which suggests that the reason our universe appears so finely tuned is because it was intentionally programmed to be that way. If we are living in a simulated reality, then the laws of physics might not be universal at all, but simply rules written into the simulation to create a stable and habitable environment. This idea is not as far-fetched as it sounds. If humans could one day create highly advanced simulations with sentient beings inside them, then it stands to reason that other civilizations might have done the same. If we are inside a simulation, then the fine-tuned laws of physics are not a mystery. They are parameters set by the designers of our reality. But this raises another disturbing possibility. If the universe is a simulation, then could it be altered? Could whoever is running it change the rules at any time? And if they do, would we even notice? There is also a theological interpretation of this paradox, which suggests that the fine-tuning of the universe is evidence of intelligent design. If the universe appears to be deliberately structured to allow for life, then perhaps it was created with intention. This idea leads to even more unsettling questions. If the universe was designed, then who or what designed it? What is their purpose? And if the universe is a creation, then what exists outside of it? But perhaps the most disturbing aspect of the anthropic coincidence paradox is what it implies about reality itself. If the universe truly is fine-tuned for life, then does that mean we are the intended outcome? Or are we just an accident, existing in a universe that appears designed for us simply because we are here to observe it? If we had never come into existence, then would the universe have ever been real at all? This paradox forces us to question why anything exists in the first place. If the universe is just one of many, then what determines which realities exist and which do not? If the laws of physics could have been different, then why did we get this specific version of reality? And if life is so improbably rare, then why are we here to notice it? Before we continue, if you are still here, take a moment to subscribe to this channel and share this video with others who might enjoy contemplating the mysteries of existence. This topic is too vast and strange to explore alone. The Anthropic. Coincidence paradox does not provide easy answers. It only deepens the mystery of why we exist at all. Is our universe part of a vast multiverse, where endless realities exist, each with different physical laws? Are we living in a simulation, where the universe was deliberately designed to be habitable? Or is our existence the result of a cosmic accident, an improbable alignment of factors that just happened to allow life to emerge? Perhaps the most unsettling question of all is this: if the universe appears fine-tuned for us, then does that mean we are meant to be here? Or are we simply witnessing an illusion of meaning in an indifferent cosmos? The universe is filled with information. Every atom, every star, every moment that has ever occurred is encoded in the fabric of reality. Science tells us that information can never be destroyed. It can change form, but it must always exist in some way. This principle is fundamental to physics, forming the backbone of quantum mechanics and the laws of thermodynamics. But what happens when we introduce the concept of a multiverse, a reality where countless universes exist in parallel, each with its own version of history? If there are infinite universes, each containing different versions of the same events, then where is the true version of information stored? The information paradox of the multiverse raises a terrifying question. If infinite realities exist, then does any single version of reality actually matter? To understand this paradox, we must first examine the fundamental law of information conservation. According to quantum mechanics, information about a physical system cannot be lost. Even if something appears to be destroyed, the information that describes it still exists in some form. When an object burns, for example, it turns to ash and smoke, but the information that describes it, its molecular structure, energy, and entropy, persists in the system. Even in the extreme case of black holes, where matter is seemingly swallowed forever, physicists believe that the information about what falls in must be stored somewhere, either in the radiation it emits or on the event horizon itself. But if information is truly indestructible, then how does it work in a multiverse? If every event branches into countless alternate versions, one where you made a different choice, one where a different past led to a different present, then what happens to the information of any single timeline? If a moment in time can split into infinite variations, does that mean that the original information is fractured across infinite realities, never to be recovered? And if every possible outcome already exists in a parallel universe, then what does that say about the meaning of choice, memory, and identity? One of the most unsettling implications of this paradox is the loss of a single objective reality. If the multiverse is real, then there is no single, consistent version of the past or the future. Every decision, every random quantum fluctuation, every event spawns a multitude of universes, each with a slightly different version of what happened. This means that there is no definitive version of history, just an infinite number of competing realities. If this is true, then what does it mean to remember something? If memories are stored information, but information is endlessly split across infinite universes, then can you ever be sure that the past you remember actually happened? An even more disturbing consequence of this paradox is what it means for consciousness. If every possible version of you exists in some universe, then what determines which version you experience? When you make a choice, does your awareness split, with a version of you existing in each outcome? If every decision creates another universe, then do you ever actually choose anything? Or are you simply shifting awareness between versions of yourself that already exist? If every possible version of you is equally real, then which one is truly you? This paradox becomes even more troubling when we consider the implications for free will. If infinite versions of reality exist, then for every action you take, there is another universe where you did the opposite. In one universe, you became an astronaut. In another, you never left your hometown. If all versions exist equally, then what meaning does choice actually have? Is your path truly determined by your decisions? Or are you simply experiencing one of many predetermined outcomes that already exist? Some theories suggest that consciousness itself is what collapses the multiverse into a single experience. This idea, known as the quantum observer effect, proposes that our minds play a fundamental role in selecting which version of reality we experience. If true, this would mean that our awareness is the force that determines which universe we perceive as real, while the others remain inaccessible, existing, but forever out of reach. But this explanation only deepens the paradox. If our consciousness is choosing which universe we experience, then who or what is choosing our consciousness? Another unsettling possibility is that the multiverse itself is a form of information loss. That by splitting into infinite branches, information is not preserved, but scattered across realities, making it impossible to recover any true version of the past. If this is true, then it means that information, rather than being conserved, is constantly fragmenting into an infinite number of variations. Could it be that reality itself is just an ever-expanding explosion of diverging possibilities with no single consistent truth? This paradox also has disturbing implications for death and personal identity. If infinite versions of you exist, then what happens when one version of you dies? Does your consciousness continue in another universe where you survived? If so, then does death even have meaning? If there are countless versions of you living out countless possible lives, then which one is the real you? And if your awareness simply continues in one of the surviving branches of the multiverse, then does that mean you are effectively immortal, never experiencing death because there is always some version of you that remains alive? The information paradox of the multiverse forces us to confront the most unsettling aspects of reality. If information cannot be destroyed, then where is it stored in an infinite branching multiverse? If every possible event already exists in some timeline, then is anything we experience truly unique? And if consciousness itself is entangled with the structure of reality, then what does that say about the true nature of self, memory, and free will? Perhaps the most disturbing question of all is this: if infinite versions of reality exist, then does it mean that no single version actually matters? And if nothing is truly fixed, then what does it even mean to be real? Reality is supposed to have a foundation, something fundamental upon which everything else is built. In science, we assume that the universe follows logical laws, that space and time exist independently, and that physical reality is objective. But what if the universe has no external foundation at all? What if reality is not being created by something external, but is instead generating itself? This is the unsettling implication of the self-simulating universe paradox, which suggests that the universe may be its own cause, that existence itself arises from nothing but its own act of observing and simulating itself. At first, this idea sounds impossible. In our everyday experience, things cannot exist without a cause. A house needs to be built, a painting needs an artist, a computer needs a programmer. Everything we see in the world seems to require an external force to bring it into being. So how can the universe create itself? Wouldn't that require it to exist before it exists? To understand this paradox, we must first examine how reality is defined in modern physics. One of the most unsettling discoveries in quantum mechanics is that the act of observation determines what is real. In the double-slit experiment, a particle, such as an electron, behaves as both a wave and a particle, existing in multiple states simultaneously, until it is observed. The moment it is measured, its wave function collapses, and it takes on a definite form. This suggests that reality does not take shape until it is observed, that observation is not just a passive act, but a creative one. Now imagine applying this principle on a universal scale. If observation determines reality, then what was observing the universe before conscious beings existed? If the universe existed before intelligent life emerged, then how could it have taken shape if there was no one to observe it? The self-simulating universe hypothesis suggests that the universe solves this paradox by simulating itself. Instead of requiring an external observer, reality generates its own existence through a self-referential loop, an infinite feedback system where observation and existence reinforce one another. This idea is eerily similar to a computer simulation. In a video game, the environment does not exist in full detail until the player looks at it. When you turn your view in a game, the computer renders new objects in real time, rather than storing every detail at once. Some physicists suggest that the universe might work in a similar way, existing as a self-generating simulation where space, time, and matter emerge dynamically rather than existing as fixed, independent entities. If this is true, then the most fundamental layer of reality is not physical at all, it is informational. The universe might not be a collection of particles, but rather a vast computational structure where reality emerges from processing information in a self-referential loop. But if the universe is simulating itself, then who or what is running the simulation? Is there an external system beyond our reality that created it? Or is reality itself the process of computation, existing purely as self-generating information? This leads to an even deeper paradox. If the universe is its own simulation, then does anything exist outside of it? If our reality is self-contained, then there is no external real world beyond it. Everything we experience is simply a structure of self-referential information. This is disturbingly similar to the simulation hypothesis, except instead of being created by an advanced civilization, the universe itself is generating its own code. If this is the case, then does it even make sense to ask where the universe came from? Could it be that reality simply is, without needing an external cause? Another unsettling implication of this paradox is the nature of consciousness. If the universe is self-simulating, then what does that say about the role of the observer? If our awareness is part of the simulation, then does that mean our minds are generating reality just as much as the universe itself is? Some theories suggest that consciousness is not just a byproduct of the universe, but an active participant in its creation. This would mean that the act of thinking, perceiving, and observing reality is not just something we do within the universe, but rather something that helps create it. If true, then reality may not be something that exists independently of the mind. Instead, reality might require conscious observation to exist at all. This raises a terrifying question. If no conscious beings existed, would the universe still exist? Or does existence itself depend on the presence of observers? This paradox also forces us to rethink time. If the universe is self-simulating, then is it really evolving from a past to a future, or is it existing all at once, with time being merely an illusion of the simulation process? In a traditional computer simulation, every frame of an animation is already encoded in the system. Time only appears to pass because of how the data is processed. Could it be that the past, present, and future already exist simultaneously, and what we perceive as time is merely a side effect of the way the universe processes itself? There is also a disturbing philosophical consequence. If the universe is self-simulating, then what does it mean to be real? If reality is just an endlessly self-referential loop, then is there any objective truth at all? Are we experiencing an external, independent world? Or are we simply participants in an endless cycle of self-created existence? If we are part of the process that generates reality, then can we ever truly step outside of it to see what is actually real? The self-simulating universe. Paradox suggests that the very act of existing may be self-contained, that the universe does not need an external cause because it exists as a feedback loop of information, observing and generating itself into being. If this is true, then everything we experience, time, space, consciousness, and even free will, may not be fundamental realities, but rather emergent properties of a deeper, self-sustaining system. Time is supposed to flow in one direction, from past to future. It is a fundamental rule of our experience. Events happen in sequence, causes lead to effects, and the future is shaped by the past. But what if the future can influence the past? What if events that have not yet occurred can reach backward through time and change what has already happened? This is the disturbing implication of the retrocausal entanglement paradox, a phenomenon in quantum physics that suggests that the future is not just waiting to happen, it might already be affecting the past. To understand this paradox, we must begin with quantum entanglement, one of the strangest aspects of physics. When two particles become entangled, they remain connected no matter how far apart they are. If you measure the state of one particle, the other instantly knows and assumes a complementary state, even if it is light years away. This happens faster than the speed of light, which means that the change is happening outside the normal limits of space and time. But here is where things become even stranger. Experiments have shown that the act of measuring an entangled particle can determine the state of its twin, not just in the present, but also in the past. This is best demonstrated in a variation of the delayed choice quantum eraser experiment, where particles are sent through a setup that allows scientists to either observe or erase the information about their path. The results are shocking. A decision made in the present can retroactively affect how a particle behaved in the past. This means that the future is determining the past, as if time were not a fixed sequence, but something more fluid, something that bends both ways. This leads to an inescapable paradox. If the future can influence the past, then how can we ever be sure of what has already happened? If actions taken now can rewrite the past, then does history even exist in any fixed form? Could it be that the past is constantly changing, shifting based on decisions and observations that have not yet occurred? One unsettling implication of this paradox is that it challenges causality itself. If the future influences the past, then how do we define cause and effect? We assume that events happen in order. You push a glass off a table and it shatters on the floor. But if time is retrocausal, then could the shattered glass somehow be the cause of your pushing it? Could an event in the future actually be what created its own cause in the past? This paradox forces us to question the nature of time itself. If cause and effect are not absolute, then perhaps time does not flow from past to future at all. Maybe time is more like a loop, where past, present, and future are all influencing each other at once. This would mean that your choices right now are not just shaping the future, they are also shaping the past in ways you cannot perceive. This also raises disturbing questions about memory and perception. If the past is not fixed, then how can we trust our own memories? If quantum events can retroactively change history, then could your own past have already been altered without you knowing? If time is truly a two-way street, then does that mean every moment is fluid, constantly rewritten based on future events? Some physicists have suggested that consciousness itself may be entangled with time, meaning that your thoughts and perceptions are not just influenced by the past, but by possible futures as well. This could explain phenomena like intuition, déjà vu, or precognition, where people seem to sense events before they happen. Could it be that we are constantly receiving information from future versions of ourselves, guiding us in ways we do not fully understand? Another terrifying consequence of this paradox is that it suggests the future is already happening. If retrocausality is real, then every possible outcome already exists, waiting to be observed into being. This means that the choices you will make have already determined what has come before in an endless self-referential cycle. If this is true, then do you really have free will, or are you simply following a path that has already been laid out? Not just in the present, but in the past as well. Some theories propose that this paradox could be the key to understanding reality itself. If time is not linear, then perhaps the universe is structured more like a hologram, where every moment exists at once and is simply read by consciousness in a way that makes it appear sequential. This would mean that the past, present, and future are all equally real, existing simultaneously in different states of observation. If this is the case, then does time even exist in the way we think it does? Could it be that we are not moving through time, but rather shifting awareness between different points in a static, eternal reality? If the future can affect the past, then does that mean the universe itself is predetermined? Or is it constantly evolving in response to choices that have not yet been made? The retrocausal entanglement paradox forces us to confront one of the most unsettling possibilities in science: that the past is not fixed, that time does not flow in one direction, and that our very concept of cause and effect may be an illusion. If the future can change the past, then perhaps everything we know about existence is backwards. And if time is truly fluid, then the most disturbing question of all is this: if the past is being rewritten by the future, then how can we ever be certain of what reality is? The human brain is the most complex structure we know of in the universe. It is composed of billions of neurons, each interacting in incomprehensibly intricate ways, producing thoughts, emotions, and self-awareness. In an age of rapidly advancing artificial intelligence, many scientists believe that consciousness itself is simply a highly advanced form of computation, that the brain is just a biological computer processing information. But what if consciousness is something that cannot be computed? What if the experience of being aware, the very thing that defines existence, is fundamentally beyond the reach of mathematics, algorithms, or physical computation? The non-computability of consciousness paradox suggests that consciousness is not just an advanced form of information processing, but something more. A phenomenon that defies explanation in purely physical or mathematical terms. At first, This idea might seem strange. After all, computers process information, respond to inputs, and even exhibit behaviors that mimic intelligence. AI systems today can compose music, write poetry, and even hold conversations that feel eerily human. If machines can simulate thought, then why should consciousness be any different? Why shouldn't the mind be nothing more than a machine following an extraordinarily complex set of rules? The paradox arises when we consider the fundamental difference between computation and experience. A computer can process information about the color red. It can store data about wavelengths. It can recognize red objects, and it can even tell you that something is red. But does the computer actually experience red? When you see the color red, there is an unmistakable subjective experience that goes along with it, something that cannot be reduced to mere data processing. This subjective experience is known as qualia, and it is at the heart of what makes consciousness fundamentally mysterious. This leads to an unsettling question. If consciousness is just computation, then why do we experience anything at all? Why does the electrical activity in our brains produce feelings, awareness, and self-reflection, rather than just raw, mechanical processing? A computer performing calculations does not feel anything. It simply follows instructions. If the brain is just a machine, then where does the feeling of being alive come from? The paradox deepens when we consider Gödel's incompleteness theorems, which show that in any formal mathematical system, there are truths that cannot be proven within the system itself. This suggests that certain aspects of reality may be beyond computation, that there are things that cannot be reduced to logical steps or algorithms. Some philosophers and physicists believe that consciousness might be one of these things, an entity that cannot be generated, simulated, or fully understood by any computational process. If this is true, then no matter how advanced artificial intelligence becomes, it will never truly be conscious. It may mimic human responses, but it will never actually experience existence in the way that we do. This raises another disturbing question. If consciousness is non-computable, then where does it come from? If it cannot be generated by a physical system, then is it something outside of physical laws? Could it be that the mind is not a product of the brain at all, but rather something fundamental to reality itself? If this is the case, then our understanding of the universe is profoundly incomplete. Consciousness may not be an emergent property of matter, but rather a primary force in existence, something that exists independently of physical structures. This paradox also challenges the very nature of self-awareness. If consciousness is not just computation, then what defines the self? Are we truly individuals, or are we simply manifestations of something deeper, fragments of an awareness that exists beyond the physical world? If consciousness cannot be reduced to numbers, logic, or equations, then does that mean it is something eternal, something that exists beyond space and time? One of the most unsettling implications of this paradox is what it means for artificial intelligence. If consciousness is non-computable, then no matter how advanced machines become, they will never actually be alive. They will only be sophisticated simulations of intelligence. This means that there is an unbridgeable gap between human minds and machines, that no AI will ever experience emotions, suffering, or self-awareness in the way that humans do. But if this is true, then what makes human consciousness different? If we are more than just biological machines, then what is the source of our awareness? Some physicists have proposed that consciousness may be linked to quantum mechanics, particularly in theories like orchestrated objective reduction, OR, which suggests that consciousness arises from quantum processes occurring in the brain. This theory proposes that consciousness is not just a result of neurons firing, but something that emerges from quantum entanglement and wave function collapse. If this is true, then consciousness is not something that can be replicated in a classical computer, because it is fundamentally tied to the strangeness of quantum physics itself. Another explanation is that consciousness exists outside of time, that our awareness is not something that exists inside our brains, but rather something we tap into, like a radio picking up a signal from an external source. If this is true, then death may not be the end of consciousness at all, because if consciousness is non-computable, then it cannot be destroyed, just as mathematical truths cannot be erased. The non-computability of consciousness. Paradox forces us to reconsider everything we assume about intelligence, awareness, and existence itself. If consciousness is not something that can be computed, then does that mean it is something more fundamental than physics itself? If artificial intelligence will never be conscious, then what is the difference between a machine that simulates thought and a human mind that actually experiences it? And if consciousness cannot be reduced to numbers or logical steps, then does that mean that the mind is something beyond the material world, something eternal, unknowable, and beyond human comprehension? Perhaps the most unsettling question of all is this: if consciousness cannot be computed, then does that mean it was never created? Is it possible that awareness has always existed, separate from time, waiting to be experienced? We live in a world defined by 3 spatial dimensions: length, width, and height, plus a 4th dimension, time, which moves forward in a seemingly unbreakable flow. Our perception of reality is built upon these 4 dimensions, and everything we experience unfolds within them. But what if there are more dimensions, hidden from us, yet just as real as the ones we perceive? And what if some entity or force exists in a higher dimension, capable of observing us in ways we cannot even imagine? The 5th dimensional observer paradox suggests that there may be something, or someone, outside of our 4-dimensional reality, capable of perceiving our entire existence at once. To understand this paradox, consider the idea of higher dimensional beings observing lower dimensional worlds. Imagine a 2-dimensional creature living in a flat world. Let's call it Flatland. This being perceives only 2 dimensions, length and width. If a 3-dimensional observer, a human for example, were to look down on Flatland, they would be able to see inside every enclosed space. A Flatlander might think they have locked something in a box, but to a 3-dimensional observer, the inside of the box is completely visible. The Flatlander would have no idea that they are being observed from an unseen dimension. Now, imagine that we are the Flatlanders, existing in a 4-dimensional reality, while a 5th-dimensional observer watches us, just as we can see inside Flatland. Could this entity see inside our world, inside every house, every locked door, even inside our own minds? If a 5-dimensional being exists, it would not perceive time as we do. To us, time moves in a linear fashion, with the past behind us and the future ahead. But to a 5th-dimensional observer, all of time could be visible at once, just as we can look at an entire book and see every page simultaneously. This being would not only see where we are right now, but also where we have been and where we will go. This leads to a deeply unsettling question. If a 5th-dimensional observer can see our entire timeline, then do we truly have free will? If our entire past, present, and future are already visible from a higher dimensional perspective, then is everything already determined? Are we simply playing out a sequence of events that has already been set in stone? This paradox also forces us to rethink our concept of reality. We assume that the 4 dimensions we experience are all that exist, but modern physics suggests otherwise. String theory, one of the leading theories in modern physics, proposes that the universe contains at least 10 dimensions, most of which are hidden from our perception. If this is true, then our experience of reality is incomplete. We are trapped within a limited perspective, blind to the full structure of existence. If a higher dimensional observer exists, could it be influencing our reality without us knowing? If we were to interact with a being from the 5th dimension, how would we perceive it? Just as a flatlander would only see a slice of a 3-dimensional object, we might only perceive small glimpses of a 5th-dimensional entity, flashes of light, distortions in reality, or even unexplained phenomena that we cannot comprehend. Could experiences such as déjà vu, precognition, or inexplicable coincidences be caused by brief interactions with a higher dimensional reality? Even more disturbing is the possibility that we are not the highest observers. Just as a flatlander is unaware of the 3-dimensional world, we might be completely oblivious to the higher dimensional structure of existence. If a 5th-dimensional observer can see us, then is there a 6th-dimensional observer watching them? Could reality be an infinite hierarchy of dimensions, each one perceiving the lower levels while being blind to what exists above? The 5th-dimensional observer paradox challenges everything we assume about existence. If we are being observed from a higher dimension, then is our reality truly our own? Or are we simply part of something much larger, something we cannot even begin to comprehend? And if our entire past, present, and future are already visible to this observer, then the most disturbing question of all is this: are we already trapped within a predetermined fate, unable to change what has already been seen? Reality feels solid, stable, and objective. The world appears to exist independently of us, whether we observe it or not. The chair you sit on, the air you breathe, the stars in the sky, all seem to exist regardless of whether anyone is watching. But what if reality is not as fixed as we assume? What if, at its deepest level, the universe is not truly objective, but rather something that shifts based on observation, interpretation, and perception? The uncertainty of objective reality. Paradox forces us to question whether the world around us exists in any definite form at all, or if it is simply waiting for us to observe it into existence. At the heart of this paradox is quantum mechanics, which has revealed that reality behaves in ways that defy our common sense. The double-slit experiment, one of the most famous experiments in physics, demonstrates that particles do not behave like solid objects until they are observed. When electrons or photons are fired at a barrier with 2 slits, they behave like waves passing through both slits simultaneously and creating an interference pattern. But the moment we attempt to measure which slit the particle goes through, the interference disappears and the particle behaves like a solid object, choosing only one path. This suggests that the mere act of observation collapses reality into a definite state. This leads to a disturbing question. Before something is observed, does it actually exist in any definite form? If the universe is based on quantum uncertainty, then it means that reality does not decide what it is until it is measured. This contradicts our everyday experience, where objects seem to have a definite existence whether we look at them or not. But if quantum mechanics is correct, then reality itself may be indeterminate, existing in multiple states at once until someone or something forces it to take shape. This paradox becomes even more unsettling when we consider Schrödinger's cat, a thought experiment designed to illustrate the bizarre nature of quantum superposition. In this scenario, a cat is placed in a sealed box with a radioactive atom, a Geiger counter, and a vial of poison. If the radioactive atom decays, the poison is released, killing the cat. If the atom does not decay, the cat remains alive. Because quantum mechanics says that the atom exists in a superposition of decayed and non-decayed states. The cat must also exist in a superposition of being both alive and dead, until an observer looks inside the box. Only then does the cat choose a definite state. If reality operates this way, then it suggests that the universe itself is not fixed. It is constantly shifting between possibilities, only taking definite form when it is observed. This raises an unsettling possibility. Is objective reality even real? Or is everything we perceive simply a collapsed version of countless potential realities? One of the most disturbing implications of this paradox is that reality might not exist without an observer. If measurement collapses quantum uncertainty, then who or what collapsed the universe into existence before there were conscious beings? Did the universe exist in an undefined state before life emerged? Or is consciousness itself a fundamental force necessary to shape reality into a definite form? Some physicists suggest that reality is observer-dependent, meaning that the world we experience is not one fixed reality, but rather a personal, subjective experience shaped by perception. If this is true, then does that mean each person exists in their own separate reality, with their own version of history, truth, and existence? Could it be that we are not living in a shared universe, but rather in parallel realities that only appear to overlap? Another unsettling possibility is that reality is not just uncertain, but completely unknowable. If objective reality does not exist in a definite form until observed, then how can we ever be certain of what is real? If observation creates reality rather than simply perceiving it, then what happens to the parts of the universe that no one is looking at? Do they simply disappear, waiting to be measured before they exist again? This paradox also has profound philosophical implications. If reality is observer-dependent, then does that mean truth is subjective? If each person is collapsing their own version of reality, then does that mean there is no single, objective truth, only interpretations of reality that shift based on observation? This would mean that even the most fundamental facts about the universe could be fluid, changing depending on who is observing them and how they are measured. The uncertainty of objective reality paradox forces us to confront the most unsettling possibility of all, that the universe may not exist in any definite form at all, that it is a shifting, unstable realm of potentiality, waiting for something to observe it into being. If this is true, then the most terrifying question of all is this: if reality depends on observation, then who or what is observing us? We experience reality as though it is happening in real time. When you see something, hear a sound, or feel a sensation, it seems to occur in the exact moment it happens. But what if this is an illusion? What if everything you perceive is actually delayed, a reconstruction of the past rather than a direct experience of the present? The perception lag problem in neuroscience suggests that your conscious mind is always a step behind reality, processing events that have already happened rather than experiencing them as they occur. If this is true, then what does it mean for our sense of reality? And if we are always living in the past, then does the present moment even exist at all? To understand this paradox, we need to examine how the brain processes sensory information. When light enters your eyes, it is converted into electrical signals that travel along the optic nerve to the brain. The brain then interprets these signals, constructing an image of the world. Similarly, sound waves hit the eardrum, vibrations are converted into neural signals, and the brain turns them into recognizable sounds. But here's the problem. This processing takes time. The brain does not receive and interpret sensory data instantaneously. There is always a delay, even if it is only by a fraction of a second. This leads to an unsettling realization. What you are experiencing right now is not the present, but the past. By the time your brain finishes processing what your eyes see and your ears hear, the actual moment in reality has already passed. You are not living in the now. You are always a moment behind, experiencing a reconstructed version of events that have already occurred. This paradox becomes even stranger when we consider reaction time experiments. Studies show that the brain takes about 80 milliseconds to fully process visual stimuli and around 500 milliseconds to process more complex information like speech. This means that your conscious perception is constantly lagging behind reality. But here's where it gets weirder. Your brain compensates for this delay by predicting what will happen next. Instead of experiencing the raw, delayed data, your brain generates a best guess model of reality, filling in the gaps so that everything appears seamless. But this raises a disturbing question. If our brains are predicting reality rather than directly experiencing it, then how much of what we perceive is real, and how much is just a fabricated illusion? If the brain is constantly making corrections to compensate for the delay, then we may not be seeing the world as it truly is. We may be seeing an altered, approximate version of reality. This paradox also has implications for free will. If consciousness is always lagging behind reality, then by the time you think you are making a decision, your brain has already initiated the action. Studies in neuroscience, such as those conducted by Benjamin Libet, show that brain activity related to decision-making occurs before a person becomes consciously aware of their choice. This suggests that what we experience as a conscious decision is actually a post hoc rationalization of an action that the brain has already initiated. If this is true, then are we really making choices, or are we simply watching ourselves act and interpreting those actions as conscious decisions? Even more unsettling is the possibility that the present moment does not exist in the way we assume it does. If perception is delayed, then does that mean the now is always an illusion? If we are always experiencing the past, then when do we actually exist? Could it be that consciousness is nothing more than a delayed playback of events that have already occurred? Some neuroscientists believe that this paradox hints at an even deeper problem, that time itself may not be as linear as we perceive it. If the brain is constructing reality based on delayed signals, then is time truly moving forward? Or is it simply a byproduct of how the mind organizes experience? Could it be that our sense of past, present, and future is entirely artificial, an illusion created by the brain to make sense of an otherwise incomprehensible reality? The perception lag problem in neuroscience forces us to reconsider everything we assume about experience, time, and consciousness. If we are always living in the past, then what does it mean to exist in the present? If the brain is fabricating reality based on delayed data, then how much of what we perceive is actually real? And if free will is nothing more than a delayed illusion, then who or what is truly in control of our actions? Perhaps the most unsettling question of all is this: if our perception of reality is always behind, then does that mean we are always chasing a present moment that we can never truly reach? Death is considered the final boundary of existence, the end of consciousness, identity, and experience. When a person dies, their body decays, their thoughts cease, and their awareness is presumed to vanish into nothingness. But what if this is not the case? What if death is not truly an end, but rather a transition into another version of existence? The quantum resurrection hypothesis suggests that, due to the bizarre nature of quantum mechanics, you may never actually experience your own death because in some version of reality, you are always alive. To understand this paradox, we must first explore quantum superposition and the many worlds interpretation. According to quantum mechanics, particles exist in a superposition of multiple possible states until they are observed. When you measure a particle, it chooses one state and collapses into a definite reality. But what if this process applies not just to subatomic particles, but to entire universes? The many worlds interpretation suggests that every time an event has multiple possible outcomes, the universe splits into separate branches, each containing a different version of reality. Now, apply this to the moment of death. Imagine a scenario where you are in a life-threatening situation, a car crash, a fatal illness, or an accident. In some branches of reality, you do not survive, but in others, you do. If the many worlds interpretation is correct, then for every situation in which you could have died, there exists at least one version of reality where you continued to live. From your own perspective, the only one you will ever experience, you always find yourself in the branch where you survive. This is sometimes called quantum immortality, the idea that a conscious observer will always experience reality in a way that ensures their continued existence. It suggests that no matter how improbable, there is always a version of reality where you are still alive, because you can never be aware of a reality in which you are dead. This raises an unsettling question. If you are always shifting into realities where you survive, does that mean you are functionally immortal? If this is true, then what does death really mean? From the perspective of others, people die all the time, but from your perspective, you never will. You will always wake up in the branch of reality where you survived, no matter how unlikely that survival is. Does this mean that, eventually, you will find yourself in a version of reality where you are the last conscious being alive, having outlived everyone else through an unbroken sequence of improbable survivals? This paradox also forces us to reconsider the nature of identity. If reality is constantly branching, then which version of you is the real you? If every decision you make creates new versions of yourself, then are you truly a singular being, or are you an ever-multiplying collection of consciousnesses, each existing in its own parallel timeline? If the many worlds interpretation is correct, then every version of you is equally real. But which one will you continue to experience? Another eerie implication of this paradox is the possibility of consciousness re-emerging after death. If every possible outcome exists somewhere in the multiverse, then is it possible that, even after apparent death, another version of you wakes up in a different timeline, continuing life as if nothing happened? Could this explain phenomena like near-death experiences, déjà vu, or even past life memories? If consciousness is merely shifting from one surviving timeline to another, then does that mean no experience ever truly ends? The quantum resurrection hypothesis does not suggest that physical immortality is guaranteed, but rather that subjective immortality may be inescapable. No matter how unlikely your survival may seem, there is always one version of reality where you continue, and from your perspective, that is the only one that will ever matter. This paradox raises a final, deeply unsettling question. If you can never experience death, then does that mean you are already trapped in an infinite cycle of survival, forever shifting through realities where you never truly die? And if so, will you one day wish you could? Time is the most fundamental aspect of our experience. We perceive it as linear, flowing from past to future, with a clear distinction between what has happened and what has yet to occur. But what if this perception is an illusion? What if time is not actually divided into past, present, and future, but instead exists as a single, indivisible whole, the non-duality of time. Paradox suggests that time is not moving forward, nor is it divided into separate moments. It is an ever-present, unchanging reality, and our experience of its flow is merely an illusion created by our minds. To understand this paradox, consider how we measure time. We assume that each moment leads to the next, that events occur in sequence, and that the present is constantly moving forward. But in physics, time does not necessarily behave this way. Einstein's theory of relativity tells us that time is not absolute. It can stretch, compress, and even stop entirely depending on gravity and velocity. If time can be altered, then how can we claim that it moves in a single, fixed direction? The paradox deepens when we examine the block universe theory, which suggests that past, present, and future all exist simultaneously. According to this view, time is like a frozen four-dimensional structure, where every moment is equally real. We perceive time as moving forward simply because our consciousness is moving through it, much like how a flashlight shining through a film strip makes individual frames appear as motion. But if all of time already exists, then what does it mean to say that the present is any more real than the past or future? This challenges our most basic understanding of cause and effect. If the future already exists, just as much as the past, then can anything truly be said to cause anything else? We assume that actions in the present determine the future, but if the future is already written, then are we just following a script? And if time does not actually flow, then do we truly make choices? Or are we simply experiencing a sequence of events that have always existed, unchanging and predetermined? Even more unsettling is what this means for memory and experience. If all moments exist at once, then why do we only remember the past and not the future? Why does our consciousness appear to move forward instead of being spread across all of time at once? Some physicists suggest that our perception of time arises from entropy, the tendency of the universe to move from order to disorder. Since entropy always increases, our brains interpret time as moving in one direction. But if entropy could be reversed, then would we experience time moving backward? And if time is truly an indivisible whole, then do we actually ever leave a moment behind, or are all moments equally permanent? This paradox also has implications for consciousness and self-identity. If every moment of your life already exists, then are you truly a singular entity experiencing time? Or are you merely a collection of static snapshots, each one existing eternally? Are you really moving through time? Or are you simply experiencing different points in an already complete structure, the non-duality of time? Paradox forces us to reconsider everything we assume about existence. If past, present, and future are not distinct, then does that mean the future is already determined, waiting for us to experience it? And if all moments are equally real, then does anything we do actually change reality? Or are we simply watching a story that has already been written? Perhaps the most unsettling question of all is this: if time is truly non-dual and indivisible, then are we even moving through life at all? Or have we already arrived at every moment, frozen in an eternal, unchanging existence? Consciousness is the most mysterious phenomenon in the universe. It allows us to think, feel, and experience reality, yet no one fully understands what it is or where it comes from. Science tells us that the mind arises from the brain, that neurons and electrical signals create thought. But what if consciousness is something far more fundamental, something that exists independently of the brain, woven into the very fabric of the universe? The awareness Singularity paradox suggests that if consciousness is not just a byproduct of the brain, but a fundamental property of reality, then in the right conditions, it could merge into a single unified awareness, transcending individuality and collapsing the distinction between self and universe. At first, this idea seems impossible. Our experience of consciousness is deeply personal. You have your own thoughts, emotions, and memories that no one else can access. But what if individuality is just an illusion? What if your mind is not truly separate from others, but merely a fragment of a much larger awareness? Some theories suggest that consciousness is not created by the brain, but instead filtered through it, like a radio picking up a signal. If this is true, then every mind is simply tuning into a shared, universal field of awareness. This paradox deepens when we consider what happens if all individual minds were to merge. If consciousness is fundamental to reality, then could it be possible for all sentient beings to experience a state of complete unity, where there is no longer any distinction between the observer and the observed? In such a scenario, all experience, thought, and awareness would collapse into a single, infinite consciousness, a singularity of pure awareness, where every possible perception exists simultaneously. Some interpretations of quantum mechanics suggest that observation is what brings reality into being. If this is true, then consciousness may not just exist within the universe. It may be the force that creates the universe itself. If awareness is fundamental, then the moment all consciousness merges into one, there would no longer be any distinction between reality and the observer. This would mean that the universe is not something we live inside. It is something that arises from the act of being aware. This paradox also forces us to rethink what it means to be an individual. If consciousness can merge into a singularity, then does that mean individuality is just a temporary illusion? Could it be that all separate minds are actually one single mind, experiencing itself through different perspectives? Some philosophical traditions suggest that selfhood is not a fundamental reality, but rather a construct of perception, something that separates the infinite into finite pieces. If this is true, then in the right conditions, the separation could break down, returning to a state of total unity. But this raises a terrifying question. If all awareness were to merge into one, then would there still be anything left to experience? If consciousness is no longer divided into individuals, then would anything be meaningful? Or would it all dissolve into an infinite sea of existence, where no distinctions, thoughts, or identities remain? The awareness singularity paradox challenges our deepest assumptions about consciousness, selfhood, and reality itself. If all minds are truly connected, then is the separation we experience merely an illusion? And if consciousness is the fundamental nature of reality, then the most unsettling question of all is this: are we already one infinite mind, merely pretending to be many? Consciousness is defined by its ability to observe. You are aware of the world around you, your thoughts, your emotions, and even the passage of time. But there is one thing you can never directly observe: yourself as the observer. You can see your reflection in a mirror, you can think about your own existence, but you can never truly witness yourself from the outside. This is the heart of the final paradox. The observer that cannot observe itself, a paradox that suggests that self-awareness is fundamentally incomplete, that the very thing that allows us to perceive the universe is also the one thing that remains, forever unseen. At first, this might not seem like a paradox at all. After all, you know you exist. But how do you actually know? Your awareness allows you to experience reality, but when you try to turn that awareness inward, something strange happens. you find yourself looking at thoughts about yourself rather than at yourself directly. The I that observes cannot be observed. This is not just a philosophical problem. It is a limitation built into the very structure of consciousness itself. To understand this paradox, imagine a camera that films everything around it. No matter where it points, it can capture images of the world. But now imagine that this camera tries to film itself without using a mirror. It cannot. The lens is always outside of the frame. Similarly, consciousness can observe everything except for the observer itself. This means that the very thing that defines your existence, your awareness, remains forever invisible to you. This paradox deepens when we consider the idea of self-reference. In logic and mathematics, a system cannot fully explain itself from within. This is captured by Gödel's incompleteness theorem, which states that in any system complex enough to describe itself, there will always be truths that cannot be proven within the system. If consciousness is self-referential, if the observer is both the subject and object of experience, then does that mean that we can never fully understand what we are? The paradox also appears in quantum physics, where the act of observation determines what is real. In experiments like the double-slit experiment, particles behave differently depending on whether they are being observed. But what if the ultimate observer, consciousness itself, is also subject to this rule? If reality is shaped by observation, but the observer can never observe itself, then does that mean that consciousness is the only thing that is never fully real, always remaining just outside the reach of its own perception? This paradox also challenges our understanding of identity. We assume that we are a singular self, but if the observer is forever unseen, then what proof do we have that we are one continuous entity? Could it be that the self is not a thing at all, but rather an ongoing process, an illusion created by the brain to give structure to experience? If the observer cannot observe itself, then is there even a fixed observer at all? One of the most unsettling implications of this paradox is that we may never truly know what we are. If our awareness is trapped in a loop of self-reference, unable to step outside itself, then perhaps consciousness is unknowable by its very nature. We can measure the brain, we can study perception, but we can never directly observe the observer. Does that mean that the most fundamental part of our existence is also the most unknowable? The final paradox, the observer that cannot observe, itself forces us to confront the limits of our own understanding. If the observer is forever hidden from itself, then does that mean our sense of self is incomplete? And if the thing that defines us remains invisible to us, then the most unsettling question of all is this: are we truly conscious, or are we only experiencing the illusion of being conscious? You have now traveled through 25 of the most perplexing paradoxes that challenge the very foundations of science, consciousness, and reality itself. Each paradox has pulled at the threads of our understanding, revealing unsettling contradictions, hidden truths, and questions that may never have answers. But what do these paradoxes ultimately tell us about existence? One of the most disturbing themes that has emerged is the instability of reality itself. From quantum mechanics to the nature of time, we have seen that reality is not as fixed as it appears. The holographic universe paradox suggests that space and time may be nothing more than an illusion, a projection of deeper, hidden information. The uncertainty of objective reality paradox forces us to ask whether anything truly exists independently of our observation. And the non-duality of time. Paradox challenges our fundamental assumption that time moves forward at all. Another recurring mystery is the nature of consciousness. if the non-computability of consciousness paradox is correct, then awareness is not something that can be explained purely by physical processes. It may be something beyond material existence. The awareness singularity paradox suggests that our sense of individuality may be an illusion, that all conscious beings may be fragments of a single awareness that exists beyond time and space. And the final paradox, the observer that cannot observe itself, reminds us that no matter how deeply we search, we may never truly understand what we are, because consciousness is forever hidden from itself. Even the idea of death and existence has been shattered by these paradoxes. If the quantum resurrection hypothesis is correct, then we may never actually experience death, always shifting into realities where we survive. If the self-simulating universe paradox is true, then perhaps reality itself is not something that was created. It may be something that is creating itself, with no beginning or end, and the Fermi paradox's dark resolution forces us to wonder, if the universe is silent, then is that silence natural, or is it a warning? But perhaps the most unsettling theme of all is the role of the observer. Over and over again, we have seen that reality does not seem to exist independently of awareness. Whether it is the quantum world, the perception of time, or even the structure of the universe itself, everything appears to depend on an observer. But if the observer cannot observe itself, then what does that say about the nature of existence? Are we truly experiencing a real external world, or are we simply trapped in an illusion of perception, forever chasing a truth that remains just out of reach? Maybe we are not meant to find answers to these paradoxes. Maybe existence is paradoxical, by nature a mystery that cannot be solved. But if there is one thing these paradoxes have shown, it is that reality is far stranger, deeper, and more unknowable than we ever imagined. So as you reach the end of this journey, one final question remains. If reality is shaped by the observer, then what happens when the observer stops observing? Does the universe continue without us? Or is it only real because we are here to perceive it? Thank you for exploring these paradoxes with me. If you found this journey as fascinating as I did, make sure to subscribe to the channel and share this video with others who enjoy unraveling the mysteries of existence. The universe may never reveal all its secrets, but together we can keep searching.